Hello YouTube, RJ. In our last episode of The Magic of the Duplexer, we looked at what it is, how it works, and why we need one. In today's episode, we're going to move from computer and theory to the bench and real world. We'll build it, then we will connect to our spectrum analyzer and VNA to test and tweak on it. Let's see how good we can get it. Remember, our goal was to get the input impedance as close to 50 ohms as possible across a wide set of frequencies, giving us a low SWR for all the different frequencies the mixer may output. This way we prevent reflected signals from returning to our mixer. This would cause additional mixing products. We also would like to get some amount of filtering that would limit the harmonic levels that reach our crystal filter. Let's jump on the bench and get started. And what I'm going to do is throw a little bit of solder on these pads, getting prepared to build this little circuit to test out for us. It says it's warmed up. Let's get a little solder on there and see. Wow. Okay. Let me tin this a little and we'll see if we can get it stuck down. Boy, it heats. It heats where you put it quick. Let me trim this inductor a little and I'll get him thrown on there real quick. I don't want leads longer than I need, so I'm going to try to keep the lead length down. Get my tweezers. Sorry about the reach. I don't want to burn myself. This is just an experiment. This is a little experimental board to see how this circuit works. Obviously, I'll go to a PCB if it works well. All right, now that I've got the Diplexer built as we designed it, I've got it hooked up. First thing I've done is I went ahead and put some SMA coax connectors onto it here to so we could connect it up. We've got it connected up to the spectrum analyzer, and we're taking a little sample of what we see coming through. We pretty much get what we expect. Now, one question is, what is the value of the components on here? Well, they're not exactly what we did. I had to play with them. One reason is this is the best I could do as far as getting exactly what we wanted for a small inductor. That's a pretty small inductor that we came up with. So the best I could do was a 0.22 microhenry, which I ordered. I had to wait on this, order it and get it in. I've got a couldn't get a 1 point, I forget what it was, 1.6 or whatever picofarad. I've got a 1 picofarad capacitor up here in parallel with that. Everything else is pretty much the way we expected. I played with this core and wrapped until I got 4 microhenries. Then what I've done is played with it a little bit once I got it on there. And if you see, I've got it pretty close. If you look at the peak marker number 1, I've got the center is 11.0592, which is the frequency we're working with. And I've got the marker set there, and you can see it's not quite at the top peak center of our lowest loss. And how you deal with that, and one of those things that I wanted to show, you get your inductors as close as you can, and then I'm going to go in here. I'm just going to play with the spreading them out a little bit, and look what happens. I can play and move that around a little. And so what you do is you just play with it. See which way is going which way, and you play with it until you get it just where you want it. A little tuning going on here, okay? Once you get it like that, where you're happy with it, you say, RJ, okay, but what happens when we jostle this around? Well, one, this is a prototype board. We're not going to be using this board. I'm going to have a PCB made. I'm not going to, at this point, lock this in, but how I lock it in is, that's where our friend Q-dope comes in. That's the reason we made our own Q-dope back a while ago, is once I have this on the finished board and I have tuned it precisely where I want it, a good coating of Q-dope, and she glues in. She's there to stay. So that's what we'll do when we get to that point. We've peaked the filter out at the frequency we want. We've got filtering going on as expected. So the next step is, since we've got that filter that we were looking for, or we're passing the frequency we want, we're kind of routing the rest the other way. How about our impedance that we were worried about? That's a very important part of what we want from this. That's more important probably than the filtering, although it's nice to have some filtering. Well, for that, I'm going to bring in the Nano VNA, and I'm going to hook it up to the Nano VNA, and we're going to see how we made out on that area. So let me get this disconnected, get the Nano VNA connected up, and we'll take a look at just how we turned out with that. So be right back. Okay, I've set up the Nano VNA, and the Nano VNA is calibrated. I've got the load left on her here, and if we take a quick look, we can see that it's calibrated. And so what I'm going to do is I'm going to take the 50 ohm off, and I'm going to move it over and put it on the filter, and I'm going to go ahead and hook up the Nano VNA now. Okay, so now we're all hooked up. We're terminated in 50 ohms. We're connected up to it. Let's see what this thing looks like. So let's do a sweep. Not too bad. Look at how low the SWR is across. We start getting a little at the end, but it's really flat, which is what we wanted. Just exactly what we were looking for. Now, is there a way we can know that this is working the way we theorize that it works the way it's supposed to work? Well, yes, absolutely. What I've got here is the short. So what I'd like to do is I'm going to take the load off, and instead of having the load here, what if we were to short this out? Now think about what that's going to do now. We're going to short this leg of our diplexer out. So if we short this out, what does that mean? Well, it means that any frequencies that are being directed down this path are going to have an outrageous SWR, right? I mean, so we should see a spike as we approach the frequency of 11.0592. We should become, our SWR should climb and go all, out of sight. So let's see if that's what we get. Let's do a sweep that way. And yes, look at that. We go off the scale way above 25 to 1. And it's centered right in the area that we are targeting. And in fact, it's so far off the scale I can't even get to it. But you can see that it's probably, if I was to increase the segments, give me just a second, I'll increase the segments, we'll be able to get a little better view of that. Okay, increase that to 11 segments. What does that do? Well, if you're not that familiar with the Nano VNA and its software, what it does is the Nano VNA has 101 points. So this is made up of 101 points. So when I get up here, I've only got a couple points. It's jumping, since we're going up so steeply, it's jumping up and down a lot. If in the software, you can tell it, okay, break this up in 10 segments. So take 101 readings 10 times as you go through this to get me more precise, closer together points. So if we sweep now, it's going to be much finer, you'll see. Takes a little longer. See it draw it Takes a lot longer to do, but it's much finer now. So what that's going to do for me is allow me to come up here, and I'm going to have a lot more points a lot closer together. And I can see that somewhere up there, that's in the ballpark of the frequency I'm looking for. Looks like we get up around 35 to 1 at one point at 11.235. So pretty close to the frequency we're looking for. So I think that kind of proves that we're getting what we are looking to get. If you just think about, we've shorted out, but it's limited to the frequency range we're working with. It means that we're only dealing with this leg at that frequency. Everything else, to be one-to-one almost, has to be coming and being shorted through this 51 ohm resistor. So all of these frequencies down here that are close to one-to-one, it's because they're routing through here. So this is working just the way we want, and I'm happy. It's going to do what we need. So now we're going to move this over to a PCB. Now you might have noticed in earlier videos on my diode mixers, I haven't made a professional PCB for them yet. For the modulator, diode ring for the IF, and for the modulator, I built them up as protos and never did anything with them on the circuit board. And the reason is I'm going to make this board, build it into the diode ring mixer, so our diplexer is on the same board. And I'm also going to place another area for another diplexer called an audio diplexer for when you're using it as the modulator. So of course you have two ring diodes in there. You'll have one that's a modulator demodulator, and you'll have one that's an actual IF. And so I'll design the board to allow you to do that all on one board. That's why I haven't done the diode ring mixer board yet. So I will design this all together, and I will build it up as one unit. And in a future video, I'll demo that out, let you see what the board looks like, and let you see, how you can add these circuitries in there to make your ring mixer better. I hope you learned something. I hope you enjoyed it. And if you liked what you saw and you haven't subscribed, do me a favor and subscribe to the channel so that you can keep up with what's going on. Helps me out greatly. It really makes a difference. Also, if you liked what you saw, hit the like button. That also helps me. And if you don't want to miss anything I do, click the notify bell. That'll make sure you see every video I put up as soon as it comes out. So thanks a lot. I hope to see you in a future video.